Right, now let us have a look at question 4. Question 4. We are given a sketch below for the graph of f of x equals to 2 to power x minus 4, which is an exponential function. For x is an element of values from -2 included to +4 excluded. You would see on our graph here, the graph starts at -2 along the x-axis, +2 included. You will see with this solid circle up to +4, and the +4 is not included, hence on the graph you would see the open circle. A and B are respectively the y and x intercepts of f, respectively, meaning A is the y intercept and B is the x intercept. Now question 4.1, write down the equation of the asymptote of f. Now we know that for any exponential function, the equation of an asymptote is given by y equals q. Therefore, on our equation we can see that the value of q here is -4. Therefore, for 4.1, the equation of the asymptote is equals to, will be y equals to -4. And 4.2, determine the coordinates of b. B is the x-intercept. This means for the graph of f of x, let us calculate the x-intercept by letting y equals 0. Then 2 to power x minus 4 is equals to 0. Y is equals to 0. And then let's solve for x. 2 to power x is equals to 4. 2 to power x will be equals to 4 is 2 to power 2. Powers of the same base, we equate the exponents. Therefore, x will be equals to 2. Therefore, this means the coordinates of b will be given by 2 and 0. X is 2, y is 0. And for question 4.3, determine the equation of k, a straight line passing through a and b, in the form k of x equals to. Alright, meaning we need to find the equation of a straight line passing through a and b. Equation of a straight line, we need the gradient and at least 1 point. Our equation, it is in the form y is equals to mx plus c. We need the gradient and at least another point to can find the value of c, which is the y-intercept, or we can go straight to the y-intercept if our straight line is going to pass through the y-intercept. Alright, let's start first. Let's start first by finding the gradient of AB. We know the coordinates of B, 2 and 0. Do we have the coordinates of A? Not yet. Let us now find the coordinates of A. Again, for our graph of f, A is the y-intercept. Y-intercept. We let x equals to 0. Then f of 0 will be equals to 2 to power 0 minus 4, of which it will be equals to 2 to power 0, 1, 1 minus 4, negative 3. Therefore, the coordinates of A will be 0 and negative 3. The coordinates of A, 0 and negative 3. Let us continue. Question 4.3 this side. 4.3 continues. And now let's find the average gradient between point A and B. The equation for the average gradient, m is equals to y2 minus y1 all divided by x2 minus x1. So the coordinates of A, let this be our x1, y1, and the coordinates of B, let this be our x2, y2. Then we go and substitute. Y2, 0 minus y1 minus 3. And negative times negative, positive. Therefore, we'll have 0 plus 3 all divided by x2, 2 minus x1, 0, of which it will be equals to 3 over 2. Our gradient will be equals to 3 over 2. Therefore, y is equals to 3 over 2x plus c. Now we need to find the value of c, which is the y-intercept. But we know that our straight line is going to pass through A and B, and A is the y-intercept, so we already have the y-intercept. The coordinates of A, 0 and minus 3. Therefore, the value of C will be the y-intercept minus 3. Therefore, now our equation k of x will be equals to 3 over 2x minus 3. Alright, now question 4.5, rather 4.4. We have to calculate the vertical distance between K and F. So let's first draw a rough sketch of the graph of K of x, the straight line K of x passing through A and B. So this will be our graph of K of let's just say K. Let's just say this is the graph of K. Now the coordinates of B, 2 and 0. So the x-intercept here is 2, so we can estimate that 1 will be somewhere here between 0 and 2. So this will be where x is equals to 1. Now 4.4, we have to calculate the vertical distance between K and F. So I'm just going to mean the vertical distance between K and F. Let's just draw a vertical line. X is equals to 1. From x is equals to 1, it will be a line that is perpendicular to the x-axis. Perpendicular to the x-axis. Now we need to find a distance that is between these 2 points, these 2 red points. To find the vertical distance, we are subtracting the y values. The bigger y value subtracts the smaller y value. There's no need for you to make use of the distance formula. You just need the values of y. And because the distance is always positive, you will always say the bigger y value subtracts the smaller y value, meaning the y value of the graph that is above subtracts the y value of the graph that is below. Therefore, we need the values of y, of k and f, where x is equals to 1. Let's start first by finding k of 1. K of 1 will be equals to 3 over 2 into 1 minus 3. Remember, we have already calculated the equation of k. So k of 1 will be equals to minus 3 over 2. Then now this is k of 1. Now let's find f of 1. F of 1, the graph of f of x, 2 to power x minus 4. Therefore f of 1, 2 to power 1 minus 4 will be equals to minus 2. This is our f of 1. Therefore the vertical distance will be equals to the y value of the graph that is above, which is k. Y value of k of 1 minus y value for f of 1. K of 1 minus 3 over 2 minus f of 1 minus 2 minus plus. Therefore vertical distance will be equals to minus 3 over 2 plus 2, which will give us 1 over 2. Our vertical distance will be equals to 1 over 2. And then now question 4.5, we have to write down the equation of g if it is given that g of x is equals to f of x plus 4. Right, we are given that g of x is equals to f of x plus 4. What is f of x? F of x is 2 to power x minus 4. Therefore we add 4. G of x, therefore our g of x will be equals to minus 4 plus 4, 0. Therefore g of x will be equals to 2 to power x. Now 4.6, question 4.6, we have to write down the domain of g inverse. We have to write down the domain of g inverse. Alright, number 1, we know that to find the inverse of a function, it is reflection about the line y is equals to x. And when you reflect about the line y is equals to x, the rule is that you interchange the values of x and y. X changes to y and y changes to x. So now remember, now our graph has endpoints. So the domain and the range, it won't just be simply x element of real numbers or y greater than the value above the line of the asymptote. We have the endpoints, so we need to consider these endpoints. So what we are going to do, we are going to find the corresponding y values of our endpoints. So this is our first endpoint and this is our second endpoint. So for the first endpoint, it's where x is -2. What will be y? We are going to substitute -2 in our equation of f. 2 to power -2 minus 4, use your calculator, and it will give you negative 15 over 4. When you substitute negative 2 on the equation of f of x, 2 to power negative 2 minus 4, yes, negative 15 over 4. Now the second end point, it is where x is 4. This is our second end point where x is 4. What will be the corresponding y value? You substitute 4 on the equation of f. Then 2 to power 4 minus 4 will give us 12. Alright, now these are the endpoints on our equation of f of x. Now we need to find the endpoint on the equation of g of x. What are end points of g of x? G of x is equals to 2 to power x. Now what is the difference between g of x and f of x? It is that f of x we have minus 4, g of x we do not have that minus 4, it's just 2 to power x. Therefore it means what? The graph of g, it is the graph of f shifted 4 units upwards. Shifted 4 units upwards. Therefore endpoints of g of x, the first endpoint will be given by, we are going to take the graph of f and then we are shifting it 4 units upwards to get the graph of g. And then when you are shifting upwards, downwards, only the y values gets affected. Therefore the first endpoint on the graph of g will be having minus 2, and that negative 15 over 4, you add 4. Negative 15 over 4 plus 4 will give us 1 over 4. And the second endpoint, it will be 4, and on f it was 4 and 12. Therefore on g, 12 plus 4 will be 16. Therefore now these are the endpoints for what? For g. Now we are ready now to find the domain of what? Of g inverse. How do we find the domain of g inverse? You simply find the range of g. Remember the inverse reflection about line y is equals to x, interchange x and y, as well as with our domain and range. So if we have the range of g, we have the domain of g inverse. So what is the range? What is the range of g of x? The range of g of x, range along the y-axis. Along the y-axis, we will be starting from the first endpoint, y value 1 over 4, and the second endpoint, stopping at the second endpoint with the y value of 16. Meaning our graph of g starts from 1 over 4, goes up to 16. Therefore our range, y element of values from 1 over 4 to 16. Now the question is 1 over 4 not negative. Is 1 over 4 included? Yes. The circle is solid, therefore we make use of the square bracket here. And 16, is 16 included? No. On the second endpoint the circle is open, therefore not included. Then we make use of the open circle. Then this will be our what? Our range. Therefore domain domain of G inverse will be given by, remember, interchange x and y. X, element of values from 1/4 included to 16 not included. This is in interval notation, or you can represent the same information in inequality notation, of which our range here will be y less than 16 but greater or equals to 1/4, x less than 16 but greater or equals to 1/4. That is our question 4.6. And then now the last question on question 4, question 4.7. We have to write down the equation of G inverse in the form y equals to. Alright, firstly, what is g of x? G of x is equals to 2 to power x. Now to find G inverse, what do? We interchange x and y. Y, x, 2 to power x, y. And then we solve for y. Applying the logarithms, the exponent will be equals to log of x to the base of the base, which is base 2. Now remember our original, not even original, just g of x, where is G inverse. We have already given what? The domain of G inverse. This is our domain of G inverse, x element of values 1/4 included to 16 not included. Therefore we need to include that domain here, because even when we go from our original graph, the graph of f, it is restricted. Starts from -2, it ends at +4 along the x-axis. That will be its domain. And then the graph of G comes from shifting the graph of f 4 units upwards, which is also still restricted. Therefore even the inverse will be restricted. But luckily for us, 4.6, it has guided us to find the domain of G inverse. So where we find the equation of G inverse in 4.7, let's also include that domain to say the graph of the G inverse only exists for what? For x element of values from 1/4 up to 16. 1/4 included, 16 not included.